our lesson, and first of all, let's introduce some equipment that we are going to use in this experiment. Describe this part. This part consists of three main parts. So it will just split, and this sucking the reactants for this.
It's much. So
Yeah, that's
so from menisc we can see that so we'll start now second part of our experiment, which name is titration. And so to do that we'll need the content of our boiling tube, which we make last week. So and then we need sodium hydroxide solution of 0.02 molar concentration, and so we need phenolphthalein. Also we need pipette tube. So what we are going to do, we must to fill this burette with sodium hydroxide solution. So to do that, we must test for a while that this apparatus is closed. And so we're filling this tube and it is not closed. So we're filling this tube completely with sodium hydroxide. And then after we will fill this burette, we must take our content in our boiling tube, and then so firstly we need to close it. Then it is not necessary anymore, so we must to get this content of our boiling tube, as you know from the first part of our experiment. So it is good closed. So when we finish filling this tube, we'll use our previous content of previous experiment, and we'll fill volumeter flask with this from this tube. And so the smell of this content is very sharp, as it can be seen because of propyl attenuate in this compound. So we need to add to this volumeter flask the deionized water, and we will do it until it reach 250 centimeter cube. And so we can open this tube and fill this with bottle itself. So it will just affect the rate of my time. So I'm filling it till the 250 centimeter cube. And and also how we can measure that it reached this value properly. We use menisc, and at eye level we will see that this compound reached this high exactly where and when. So we're closing this deionized water, and then we continue our experiment. So this volumeter flask is now contains deionized water plus our previous content, and so we'll leave it here. And then what do we need to do? So for my sake, I will wear glasses. So we need to get this compound and transfer the content of this compound to beaker by using pipettes as we used in the first part of our experiment. So I think every one of you remembered how we used this pipette, how we constructed it. So we must first leave the air by pressing the A button, and so we need to transfer the content of this volumetric flask to the beaker. So we must press S button to soak up the content, and so exactly the maximum value of this pipette is 10 centimeter cube, and we're transferring for a while this value of compound. So we're pressing E button to make it empty to fill this beaker, and so we do it again. So 10 centimeter cube. So, and then as you have seen, we already filled this beaker with 20 centimeter cube of this compound, and we need to fill the pipette now for 5 centimeter cube. So we're pressing S button and taking exactly 5 centimeter cube of compound and pressing S button to fill this beaker completely and fulfilling this beaker. And we're leaving pipette for now, and then we start to titrate. So this is the best view that I can recommend you now. So now we start titrating, and to titrate we need to firstly add a few drops of phenolphthalein to this compound. It's about 1, 2, 3, and 4. So here is 4 drops of our phenolphthalein, and now we starting titrate. So the value of burette is already 0 centimeter cube, and now we're starting. So firstly, we need to do some rough titration. It is the first titration, first set of experiment. So I'm putting glass here because I can't see the color change exactly. I may not see. So here we fill this beaker with 5 centimeter cube of burette content, and now here, as you can see, when we are adding the content of burette to beaker, then we may see some color change on this place, purple color change because of phenolphthalein, and now we're adding just a few drops. By a few drops to find exactly value to this titration and to get more appropriate or precise results. And now so it is a very hard work to complete because it takes a lot of time to set the burette and the contents of this experiment exactly many times, several times doing experiment. And so just a few drops. So to know exactly the color change, we must shake the content of the bead, and so shaking it and doing it again. So color didn't change. Not changed yet, but it will. So it's very hard work, as you can see. So color didn't change. Oh, it actually changed. So as we can see, color changed from the no color to purple color, and we can see that we used about 21 centimeter cube of our bead content, and now we need to do it again to get more appropriate results. And so we'll do it again and fill the beaker and bead exactly to this value at the start, at the beginning of our experiments. So this color that we got, it's not very appropriate because the color change is not so, is very sinful, and from the visual side, the more appropriate and precise result will occur when the color change will take place at the right time, when we make just one drop. So there is some big color change, and this will occur as our rough titration. So as you noticed, we must do several times this experiment to get some more appropriate results. And so to do that, we need to do this titration again. And so the second time, we need to fill this beaker with content of our previous experiments. So it's here. So we use pipette again to fill this beaker. So we're pressing S button, and then making it empty with pressing E button. So S button, so air, it's not empty, S button, and making it empty again. And so again, about 5 centimeter cube of our content is enough. So we're taking exactly 5 centimeter cube of the content, and then we must do it again. As you remembered, we're putting it away, and then we're using phenolphthalein and adding just a few drops of our phenolphthalein to this content. Just a few drops, about 1, 2, 3, and 4. So a few drops of our phenolphthalein, and then we must put this beaker to titration bead, and then we're starting it again. So it is not exactly necessary to refill this bead again, and we can use the content of the previous bead because it didn't change. So we're starting titration again. And so we knew that about 21 centimeter cube of burette content of sodium hydroxide is used on the previous rough titration. And so we may know that about 40 and about some range of values from 40 and to 45 is exactly the value that we can obtain. And so inconvenience, we're feeling this sodium hydroxide till the value of 40, and it didn't reach yet. Yeah, as you have seen, the color is changed for a while, but it was very good change of color, but for temporary. So we need to add sodium hydroxide again. So now, just by few drops, drop by drop, will help us to obtain the more appropriate results. So as you can see, it's few drops of this content. So color didn't change. So, oh, it didn't change yet, no color. And now it reached about 42 centimeter cube, and now it should change exactly. So, oh, it didn't change. Now so it changed. Yeah, it changed. As you can see, as you can notice, this experiment, this is not rough titration, this is second set of our experiment. So at this rate, the color itself reached more bright color of purple or pink color, and now we must obtain the result that we got, and now the result is about 42.2. As you can notice, using eye level or menisque, you can see. So it's about 43, and so 42.2 is the value that we got now, and so we must subtract this value from the previous one. We got previous time about 21 milliliters, and so it's about 22.2 centimeter cube now. At this rate, it's not so messed, but it's very accurate number. The change of different states, like at the rough titration we used about 21, and this time we used about 22.2. It's not, it's very precise values, and so we must do it again. And so now we need to fill this beaker again with the content of this flask. And now, so before we do that, we must clean this beaker. It's very important because we can get some uncertainties in our values at this stage of our experiment. So we must clean this beaker with deionized water, and so we wash this beaker, and then we're using pipette again. And as you may know now, we filling this pipette with 25 centimeter cube of the content in the volumeter flask. We're pressing S button, and then filling the beaker with this content. So first 10 is completed. Now second 10. Oh, we overfilled this, so some soak up, and oh, exactly. So make it empty. The second 10 centimeter cube of our content is filled now to this beaker. Then about 5 centimeter cube of the content we need. And don't forget about the menisque. And now, so we completely fill this beaker again, and now we will add about few drops of our phenolphthalein to this content. And now here is 1, 2, 3, 4 drops of our phenolphthalein. Now, as you already remembered, the content of a burette is not enough to do this experiment third time, and we need to fill this burette again with sodium hydroxide of 0.2 molar concentration. And now we'll do it. It's closed, and there is no things that we need to worry about. So we're filling this burette. Oh, it is not supposed to happen, but now we need to fill this added beaker with sodium hydroxide. So it's too much to our experiment. And so a burette is not in right angle, so we're subtracting some content here. So it reached 0, not 0, about 1 centimeter cube. We'll fill it again. So it's very important to follow the rules of the titration. So we fill the burette itself with exactly 50 milliliters of sodium hydroxide. We fill the beaker with our content in volumeter flask, and we filled it with phenolphthalein. And now we are going to make our third titration, which will be our last, and we need to fully follow the rules of titration, and we need to obtain more accurate result. So up to 20, as I said on the second set of our experiment, we will fill the beaker up to 20. Some shakes. Now again, it reached 18. If you can see from the video, it reached 19. So now we must shake it. So as you can see, there is no color change. So just a few drops. Just a few drops. And it's important to look at the beaker, at the process of our experiment, because if you look at the burette, you may have very good, like bad uncertainty value. So just a few drops. One second drop. It didn't change. So again, we used about 20.8 milliliters of our sodium hydroxide. And as we can see from the white color, the color is changed for a bright, very bright purple. And so we'll write this value again, and then we must do a table with the results and find the equilibrium constant value with these experiments. So thank you for watching this video, and leave a comment, leave a like, and follow us on the social webs. Goodbye.